Okay, so we're going to do the tangent curve just like we did sine and cosine to begin with. We're going to use our unit circle. So we're going to start at 0 on the x-axis. Oh my goodness. There we go. Okay. Can somebody raise their hand and tell me what tangent is in relation to cosine and sine? Yep. Very good. Tangent equals sine over cosine. Okay, so we might need a calculator out, so please have your calculator out. So here we have sine and cosine, so 0 over 1. Okay, in class, what's 0 over 1? 0. So at 0, tangent is 0. Then we're going to go to pi over 6. At pi over 6, the sine is 0.5 and the cosine is 0.9, so 0.5 divided by 0.9 equals what? So around at 0.6. Okay? 0.5 divided by 0.9 is 0.6. On our graph, 0.6, they're counting by 0.2, so 0.2, 0.4, 0.6. Any questions over that? There's our pi over 3. At pi over 3, we have 0.9 divided by 0.5. And what is it, class? 1.8. Okay, so we're going to go back. So pi over 3 we're at 1.8, which it's not going to let me graph there right now. So it's right below the 2. If it lets you graph there, put it up right below the 2. Right below it, not above it. Okay, then we're going to go pi over 2. At pi over 2, we have the sine, which is 0, and the cosine, the sine, which is 1, and the cosine, which is 0. And what's 1 over 0? Undefined. Okay, when we graph secant and cosecant, we knew how to graph undefined. I taught you guys how to graph undefined. Can someone raise their hand and tell me what I'm going to graph? Yeah? An asymptote, okay? When I have an undefined value, I'm going to graph a vertical asymptote at pi over 2. Very good. We're going to go back to our graph. At pi over 2, we're going to graph a vertical asymptote, which is right here. Okay, then we're going to go back to our graph and go to 2 pi over 3. At 2 pi over 3, we're at positive 0.9 over negative 0.5, which is negative and then 1.8 again. Any questions over that? So down here now, negative 1.8. Then we go to 5 pi over 6. At 5 pi over 6, we're going to have positive 0.5 divided by negative 0.9, which is our negative 0.6. which is right about here. Okay, at pi, we're going to have 0 over -1, which is just 0. Okay, you guys keep graphing the rest of it. Okay, so then at 7 pi over 6, so it should be at positive 0.6. And then at 4 pi over 3, we should be at positive 1.8. And again, it's not going to be right there, so right below the 2. At 3 pi over 2, I should have another asymptote. Then at 5 pi over 3, I should be back down to negative 1.8. At 11 pi over 6, I should be back at negative 0.6. And at 2 pi, I should be at 0. Okay. Any questions over that? So if I were to graph this, it's going to look like this going this way. Oh, doesn't want me to go there. Nope. Let me see if I switch back and forth, it'll fix it for me. No. Oh, so frustrating. Then this one should be like this, but not like, Very sad. And this is very helpful to graphing, right? That it won't let me. Do you get what it should look like, or not even at close at all? Okay, let me try this again. Oops, you go back. Okay. Let me snip it. Oh, it's not letting me do it. Okay, let's see. Try this again. Okay, so it should be like this, going up. Okay, then this curve is easier to see. Like this. And then this is just the second half of it. And they would keep going up if we had it. And this would go down like this. So it's basically this pattern just keeps repeating itself over and over again. Okay, that's why it's periodic. It keeps repeating over and over. It's like you're taking a stamp and just stamping it one right after the other. Okay. Can somebody raise their hand and tell me what this is similar to? We've graphed this shape before. What was this similar to? What is it? Not a parabola. Right, there wasn't like a parabola. Yes. What degree was it when it goes like this? What? Well, yes, or dance. What? Yeah. A cubed root, right? A cubed, not a cubed root, a cubed. Okay. It was an odd function. Odd and even functions. Remember, we did our dance, like Michael was saying. Okay. Odd, negative, even negative. Okay. So that's kind of what it is. It's basically like similar to a cubic, only the cubics didn't have absolute values. So the curve is kind of like it, but as it rises, it's going to get close to this asymptote, but never cross it. Okay, which is different than a cubic. Any questions over that? We're all good? Okay. So does this look anything like a sine or cosine curve? No. Not really. The only thing that's similar is that it keeps repeating over and over again, just like sine and cosine did. Okay, tangent functions, we have these values. Okay, the A isn't really the amplitude for tangent because tangent can go up forever and down forever. There's not a limit to how high and how low. Okay, the A value in this case is going to be the stretching and the shrinking. How wide that curve or how narrow it gets. Okay, so that's all we're going to do. This year, we're really not going to deal with any A value other than 1 or -1. So it can reflect. So it can go back and forth like this. Okay, but it won't, we're not going to stretch and shrink it. So A is a stretch or a shrink? Vertically. Okay, and then negative A reflects. Okay, and we'll show you the difference between negative tangent and positive tangent. The B value is the frequency, just like it is in sine and cosine. It's the number of tangent curves between 0 and pi. Oopsie. Okay, the frequency was different for sine and cosine because it was in between 0 and 2 pi. Tangents only between 0 and pi. Does that make sense? We're all good? So the period is also different. It's the length of time it takes tangent to repeat, okay? But the formula is going to be different. It's going to be the period equals pi divided by b now. Instead of 2 pi divided by b, tangent is pi divided by b. And you have to memorize this. Make it important. Okay? Because you're going to get it confused with sine and cosine because they're so similar. Okay? Tangent's its own weird thing. Okay? Then you're going to need to know the vertical asymptotes. And that's a completely different formula because sine and cosine do not have asymptotes. So the vertical asymptotes are x equals plus or minus pi divided by 2b. And again, you want to memorize this. Very important. Circle, star, highlight, however it is that you know that that's important. Any questions over that? Okay, identifying the period of a function. Okay, so again, the period is the time it takes to repeat, the tangent to repeat. So for this, it's going to be in between your two asymptotes, from here to here. Now I could use from here to here, but then I have a negative and a positive, which kind of can mess me up. You just can put them up there. Thank you. So we want to know from here to here. So this is 3 pi over 4, and then we're going to subtract the other asymptote, which is pi over 4. I want to make sure that the period is positive because period is a distance, so that's why I put the 3 pi over 4 first, minus the pi over 4. Any questions over that? Hold on. So we just subtract 3 minus 1 is 2 pi's over 4, which reduces to pi over 2. So the period is pi over 2. Any questions over that? We're good? Okay, find the period for B. Hannah, what did you get? Very good. So 3 pi minus a pi will give me 2 pi. Okay, so the period is 2 pi. Any questions on how I got that? We're all good? So here's my asymptote. Here's the next one. So that's how I know it's 2 pi. Okay, now let's graph this. Any questions with that? Okay, for tangents, the thing we care most about when we're graphing is the asymptotes. Okay, so in order to find the asymptotes, we use the formula I gave you, which is x equals plus or minus pi over 2b. Okay, that's what we need to find first for tangent. So we're going to get x equals plus or minus pi over 2 times the b value, which is 3. So we get x equals plus or minus pi over 6. So we're going to graph an asymptote. At x equals negative pi over 6, and then x equals positive pi over 6. I'm going to count 1, 2, 3, 4, and then negative 1, negative 2, negative 3, negative 4. So this is at negative pi over 6, and this is at positive pi over 6. So negative pi over 6 is here, and positive pi over 6, and this is 0 in the middle. Does that make sense? And so here is an asymptote, and here is an asymptote. Okay. Okay, we're going to label the x-axis by counting, counting by the asymptote. In this case, it's pi over 6. So we're going to count by pi over 6s. Does that make sense? So here's pi over 6, and then we're going to do 2 pi over 6, then 3 pi over 6, then 4 pi over 6, then 5 pi over 6, then 6 pi over 6, 7 pi over 6, and 8 pi over 6. Then we can reduce. 2 pi over 6 is pi over 3. 3 pi over 6 is pi over 2. 4 pi over 6 is 2 pi over 3. 5 pi over 6 can't be reduced. 6 pi over 6 is pi. 7 pi over 6 we can't reduce. 8 pi over 6 I can get 4 pi over 3. Any questions over that? Now, the pattern for our tangent. That's one of them. This is our steps. Next one. Okay, we're going to graph an asymptote at every other x value. Okay, so once we find those initial two asymptotes, then every other x value I'm going to do an asymptote. So that means I'm going to skip this one, and I'm going to put an asymptote right here. Then I'm going to skip this one, and I'm going to put an asymptote right here. Then I'm going to skip one, I'm going to put an asymptote right here. Any questions over that? Drawing the asymptote. Okay, then you need another shape of tangent. Okay, positive tangent. Is like positive and odd function. It goes like this. It starts down and then goes up. Negative tangent. Starts up and then goes down like negative odd function. So it flips. Any questions over that? Your 0 is at 0. So right at that mark in between, those are all your zeros. And then tangent's going to start and go past 0 and go curve. It looks just like this. And it doesn't ever touch the asymptotes. It gets close to it but never touches it. Does that make sense? Any questions over that? We're all good? Okay, next one. Okay, negative tangent of pi over 3. Dan, what am I going to do first? Right, find our asymptote. X equals plus or minus pi over 2b. This is going to be a fun one because it's going to be a crazy fraction, and that's okay. So pi over 2 times pi over 3. Which equals pi over 2 pi over 3. So remember, this is like a 1 underneath it. So we multiply 2 times pi and get 2 pi, and then 1 times 3 and get 3. Any questions over that? Then you're going to get pi times the reciprocal of 2 pi over 3 is 3 over 2 pi. Then we multiply straight across. We get pi times 3 is 3 pi. And 1 times 2 pi is 2 pi. The pi's will cancel out. So your asymptotes are x equals plus or minus 3 over 2. Any questions over that? Or 1.5, however you want to write it. So we're going to graph that. Or label this 3 over 2, and label this negative 3 over 2. And then those are my asymptotes. Here, and here. Okay, then on the x-axis, I'm going to count by 3 over 2. Any questions over that? So 3 over 2 plus 3 over 2 is 6 over 2. Then 9 over 2. I'm just adding 3 to the top each time. Then 12 over 2. Then 15 over 2. Then 18 over 2. I'll stop there. So we can reduce this. 6 over 2 is 3. 9 over 2 I can leave. 12 over 2 will be 4. 15 over 2 I'll leave. And 18, thank you. Let's divide by 2. 12 divided by 2 is not 4. It is 6. And then 18 divided by 2 would be 9. Did I lose anyone? Okay, then we graph our asymptote at every other x value. So we're going to skip this one and graph this one. We're going to skip this one and graph this one. We're going to skip this one and graph this one. Does that make sense? Then this is a negative tangent. Negative tangent is this. It starts up now and goes down. These are all zeros. All these, every other one are going to be zeros. And then tangent starts here and goes down. Tangent starts here and goes down. Tangent starts here and goes down. Any questions over that? We're all good? Okay, do the next one on your own. Okay, Serenity, what were my asymptotes? Pi over 4. Do you agree, class? Yes. So we should have pi over 4 here, and pi over 4 here. Negative pi over 4, I should say. Then this should be pi over 2, then 3 pi over 4, then pi, then 5 pi over 4, then 3 pi over 2, and then it's 6 over 4, then 7 pi over 4, and then 2 pi. We're good? Okay, our asymptotes should then be here, here, and every other one. Any questions over that? Okay, and then our positive tangent should go like this. So this is a 0, and it should look like this. This is a 0, and it should go like this. This is a 0, and it should go like this. Oh, now it's going to get stuck again. Okay, I love that it freaks out on me sometimes. But you guys should get the idea, correct? Any questions on how I got that? We're all good? Okay, now let's do the pattern of cotangents. Okay, cotangent is different. You do not have a formula for asymptote for cotangents, okay? You have a period for cotangents. You care about the period for cotangents, okay? We're going to graph this using our unit circle again. So I'm just going to tell you what the x and y value should be, what the x and y axis should be. So just count by 0.5s. Let's do that better. On the y-axis, 0.5, then 1, then 1.5, then 2, then negative 0.5, then 1, negative 1, then negative 1.5, and then negative 2. I'll show you how to get these values on the next one, on G. On this one, we just want to use our unit circle, so I'm going to use the values that we did for our very first tangent. I'll keep going back. From this one, we're going to use those same values, pi over 6, pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, all those. So it's going to be pi over 6, pi over 2, pi over 3. Let's try that again. Which one's bigger, pi over 3 or pi over 2? Yes. So this should be pi over 3 first, then pi over 2. Sorry. Then we're going to do, so this is 2, no. Then it should be 2 pi over 3. Then 5 pi over 6. Then pi. And we'll just stop there at pi. Any questions? Okay, so again, I'm just giving this to you. It's a given. It's not anything that I calculated or anything like that. So we're going to go 0 on our unit circle. Okay, can someone tell me what cotangent's going to be in relationship to sine and cosine? Raise our hands. One person? Anyone else want to try? Yeah? Cosine over sine. Tangent was sine over cosine, so cotangent equals the reciprocal, cosine over sine. So here, it's going to be 1 over 0, which is what, class? Undefined. Okay, so we're going to go back to here, and we're going to graph our asymptote. And it's going to be at 0 this time. Then we go back to our unit circle. Then at pi over 6, it's going to be cosine, which is 0.9 over 0.5, which we found to be 1.8. So it's going to be at 1.8, which is kind of closer to the 2. Then pi over 3 is going to be 0.5 over 0.9, which was 0.6. Which is a little bit above the 0.5. Then pi over 2 was at 0 over 1, which is 0. Then at 2 pi over 3, it's going to be at negative 0.5 over 0.9, which is negative 0.6. Which is right about here. Then at 5 pi over 6, we're at negative 0.9 divided by 0.5, which is negative 1.8. Are you guys following this okay? I'm not going too fast? Good. So that's, again, closer to the 2. Oopsie. Right there. And then at pi, it's going to be negative 1 over 0, which again is undefined. So our asymptote is at pi again. Any questions over that? So here is our cotangent curve. Okay, this is kind of similar to tangent, correct? What are some differences that we see between cotangent and tangent? Yeah? Okay, if you go back to our original one, though, it's not really wider, right? Because that was pretty spread out. Okay, this one starts up, whereas cotangent starts going down. What else? Look at your graph and look at this. What else is different? Look at the asymptotes. How are the asymptotes different? Well, for tangent, they're spread apart too. Right? For this one it is, at least. Yep. Very good. On cotangent, you have an asymptote at 0 right here. At tangent, you have your actual kind of curve through 0. Okay? So cotangent is kind of like tangent just shifted over. If I just move this over and have an asymptote here, that's cotangent, correct? Okay, and then it's also flipped. So it's a negative tangent. Cotangent is negative tangent. Okay. So let's graph now cotangent of 2 theta. Okay, so for cotangent, we don't have a formula for asymptotes. We only have a formula for asymptotes for tangent. Cotangent, we need to use the period. And the period is the same thing as it is for tangent, pi over b. So the period is going to be pi over 2. Okay. The asymptotes are always at x equals 0 and x equals the period. Okay, so we're going to group down those asymptotes. So here is 0. Okay, you can just spread this out as much as you want. Okay, I'm going to do kind of like I did tangent. Okay? To label the x-axis take the period and divide it by 2. Because we want every other one to be the asymptote, just like it was with tangent. Does that make sense? So here our period is pi over 2. We're going to divide it into 2 parts, which gives me pi over 2 times the reciprocal of 2 is 1/2, which is pi over 4. Any questions over that? So let's count pi over 4, then pi over 2, then 3 pi over 4, then 4 pi over 4, then 5 pi over 4, then 6 pi over 4. We'll stop there. I already reduced this one first because I did it in my head. I'm sorry. 3 pi over 4, then 4 pi over 4 can be pi. 5 pi over 4 doesn't reduce. 6 pi over 4 is 3 pi over 2. Now we have that first asymptote, which is at x equals 0. Then our next one's going to be at x equals the period. And our period was pi over 2. So this is going to be, our next one's going to be at x equals pi over 2. Then it's going to be just like tangent, every other one. So we're going to skip one and put the next one. Skip one and put the next one. Okay, so it's the asymptotes at every other x value. Does that make sense? Okay, that's the pattern for this. Then we need to remember what cotangent looks like. Positive cotangent is a negative tangent curve. Negative cotangent then is a positive tangent curve. And again, you just need to memorize which direction it goes. So when you're doing your homework tonight, have your notes out so you can remember which way it goes. Okay, if you don't have the notes out, you're going to be doing it wrong. You're going to get confused at some point, so please look at your notes. So here is my 0, here is my 0, here is my 0. And so cotangent starts up and goes down. Positive cotangent starts up and then goes down. Positive cotangent starts up and goes down. Any questions over that? All good? Okay, last example. Okay, the first thing we need to determine is if this is cotangent or tangent. Looking at this graph, can anyone tell me if this is cotangent or tangent, and why? Let me call on somebody. Carrington, do you think this is tangent or cotangent? And why? Is this at 0? Right? I don't have an asymptote at 0, right? So was this tangent or cotangent? It's tangent. Because tangent goes through 0, 0. Cotangent will have an asymptote right there at 0. Does that make sense? So this is tangent. So we need the b value. So f of theta equals the tangent of b. So we need to find the period first. That's the distance from here to here. So that is that pi over 4? So we have 3 pi over 4 minus pi over 4, which gives me 2 pi over 4, which is pi over 2. Okay. So then I use the formula of pi over b equals pi over 2. Now hopefully some of you guys can look at that and tell me what the b value is. Who thinks they know what the b value is? 2 people think they know. Okay, good. If you do not know, then let's solve this. You're going to cross multiply. Okay, 2 times pi is 2 pi. B times pi is b times pi. You want to get the b by itself, so you can divide by pi, so b equals 2. Any questions on how I got that? Let's look back at the original formula. Pi over b equals pi over 2. They're equal to each other. So what does the b have to be to have pi over 2? It has to be 2, right? The pi's on top match. So that's not going to affect anything about the denominator. So the denominator should also have to match. Okay. So now you're just going to plug that into your formula. So f of theta equals tangent times 2 theta. And that's it. Any questions over that? Okay, your homework is the next pages. So you just staple it backwards. So, it's 15. Oh, it is. It's 15 and 16 in your homework, in your stamp sheet. It looks like they're numbered backwards. Does that make sense? So you're just going to do trig 7. Yes. Give me 1 second.